numbers. The collection of all real numbers and irrational numbers together make up what we call the collection of real numbers, which is denoted by R. Thus, a real number is either rational or irrational, but cannot be simultaneously both. If a real number is not rational, it has to be irrational and vice versa. 3. 7 by 5 minus 1.5, 2.3, 5.76245, etc. are some of the rational numbers, whereas root 2, root 3, cube root 7, fifth root of 11, pi are some examples of irrational numbers. These are the numbers which can represent actual physical quantities in a meaningful way. These can be represented on the number line. A number line is a geometrically straight line with arbitrarily defined zero origin. Let us represent a few real numbers on the number line. 3. 7 by 5, that is 1.4, lies in between 1 and 2. Minus 1.5 lies in between minus 1 and minus 2. 2.3 lies in between 2 and 3. 5.76245 lies in between 5 and 6. Root 2 is approximately equal to 1.414, lies in between 1 and 2. Root 3 is approximately equal to 1.732, lies in between 1 and 2. Cube root 7 is approximately equal to 1.912, lies in between 1 and 2. Fifth root of 11 is approximately equal to 1.615, lies in between 1 and 2. Pi is approximately equal to 3.1415, lies in between 3 and 4. We can say that every real number is represented by a unique point on the number line. Also, every point on the number line represents a unique real number. Therefore, we call the number line the real number line. Illustration 1. Find any two irrational numbers between 1 by 5 and 2 by 7. Solution. We know that 1 by 5 equals to 0.20. 2 by 7 equals to 0.285714 bar. To find two irrational numbers between 1 by 5 and 2 by 7, we need to look at the decimal form of the two numbers and then proceed. We can find infinitely many such irrational numbers. Examples of two such irrational numbers are 0.20120111, 20111, and so on. 0.2411, 4111, 41111, and so on. 0.252, 3161, 7181, 912, and so on. 0.2678, 12, 14, 75, 12, and so on. If a and b are two positive rational numbers such that root of ab is not a perfect square of a rational number, then ab is an irrational number lying between a and b. Illustration 2. Insert a rational number and an irrational number between 2 and 3. Solution. If a and b are two positive rational numbers such that ab is not a perfect square of a rational number, then root of ab is an irrational number lying between a and b. Also, if a, b are rational numbers, then a plus b by 2 is a rational number between them. Therefore, a rational number between 2 and 3 is 2 plus 3 by 2 equals to 2.5. An irrational number between 2 and 3 is root of ab equals to root of 2 into 3 equals to root 6. Summary.